Hello, everyone. Welcome to episode 24 of the Day Zero podcast. I'm Spectre, and with me, as always, is Z. And it's been a pretty busy week. There's been some big highlight topics that have happened, and we're gonna jump right into one of the bigger ones, if not the biggest piece of news that came out of last week, and that's Shambles, which is an attack that's targeted against SHA-1. So Z, you can
Yeah,
take this one away.
I don't remember if we talked about the SHA-1 collision itself. Do you recall if we talked about that?
Oh, like in our little discussion about it
Well, no,
beforehand,
no,
or
no. So this is kind of follow-up work. Previously there was already like an SHA-1 collision being done with two PDFs. I don't remember if that happened during the
oh,
summer or not, though.
you're
Um,
talking about Shattered, right?
yes, that sounds right.
Yeah. I can't remember if we covered that. I feel like we did, just because I remember bringing up those PDFs. I feel like on the stream, so I think we
Yes,
did cover that. I just don't remember exactly when it was. It might have been
okay.
before we went on the break.
Yeah, so I think we've covered it. I guess shattered's the right term there. So, people want to find our previous discussion on it. That's there. So anyway, kind of with this one, with Shambles, this is now a chosen prefix collision. So before it was basically like, they're able to generate the two files that will collide, but they both have to have the same prefix and suffix, and then you have the different middle part is essentially how it would go. That's how just kind of like your standard collision goes. Somewhat useful, not always. Chosen prefix, the difference there is that you can have different prefixes between the two collisions. So it's a lot more useful if you want to generate, as they do, kind of as their example work is attacking the PGP keys. Um, so I guess I'll talk a little bit here with chosen prefix. I did find some previous work. So back in August, the
Thank you for your.
same team released a. Well, there's a talk. There's also a paper that comes from these guys. From collisions to chosen prefix collisions, application to full SHA-1. I've added this link here. It's good to take a look at this one. Um, all right, I guess I'll put this. It's a good talk. Uh,
I didn't
sorry.
check out the talk. Was there anything in it like that
Well,
wasn't
so
really in the paper, the
well,
slides?
so it's a different talk. It's a
Okay.
completely. That's from August. So I guess the thing with that talk is it covers all the theory that led up to this. So they had the collision. Now it's going from a collision to chosen prefix collision, which is just kind of like a new, more useful attack. Um, and then going from that, so this paper was just this video that I just show on stream was just the video. Or I'm sorry, I'm tripping over my words today, but it,
It's
it
all good.
was just the present. It was a presentation about their theory from August, so it gives you a lot of background. But to go on about Shambles itself, the reason I want to mention that it is from the same team, same people, but it's a talk. You can just kind of listen to it. It covers some things in good detail. It also skips over some stuff, but it gives you a lot. Well, the paper for Shambles is good too. It's a good talk. I'm just tossing it out there. As for Shambles, the whole thing is it's a chosen prefix collision. I've already kind of explained what that is. Comes down to using uh so what was this? 900 GPUs, I think they used $75,000 to create basically a key that would have the same hash, or that ultimately you have the same signature.
Yeah. So what this reminds me a lot of is so many of you probably don't know, but Z a long time ago had a little challenge site up, and there was like 7 challenges on it. It's obviously not up anymore. We actually have a different site in its place that we're working on. But he had a challenge on there where it was like a binary pwn, and there was a CRC32 component where you could forge hashes. So that's kind of a similar thing here with a chosen prefix. You could control, I think with CRC32, if you can control 4 bytes and the length of the input being passed in, you could forge a hash for it. This is kind of similar, although this takes a lot more processing power to pull off. Like Z was saying there, their setup, I think they said, cost $75,000. They do admit, though, that is because, they were having some issues trying to, through the research, right? So it's not going to be perfect. They say that now that they've figured out the attack, I think they said it would be about 45,000 to pull it off today. But they said that'll decrease over time, obviously.
So they did mention that they had a lot of extra costs as they were tuning the attack itself. So that's part of where that comes from too. And I mean, they used the GTX 1060s. They can get things faster on different 1060s. Even a 1060 Ti would be faster. I don't know if they'd get much benefit off the 2080s. Or even 2060, but using that 20 series is also another possibility. Once it's up there. But that actually brings up kind of an interesting point, which is rather than going for the data center grade GPUs, they just went and were renting cheap GPUs from providers that use gaming cards. You might have a GTX 1060 in your computer right now. They use the consumer grade stuff and just rented that.
Have a 1060.
Yeah, so
there we go.
So I mean, they use consumer level stuff, which did bring down the cost of it. And I will talk a little bit actually about most of the cost is in what they call kind of the birthday stage. So there's 2 stages to this. There's the birthday phase, and then there's I would use the term trail building. I'm not sure if that's necessarily accurate. It's definitely kind of touching beyond kind of the edge of my crypto knowledge. But one of the things that they kind of worked on with this whole paper with trying to get this collision is creating 2 prefixes that have, I'll go ahead and define what I mean by trail building or building trails is where you find certain input bits that have a high probability of impacting the output. And so with that, it's not like a direct relation. It's not like you set this bit, it's going to be set in the final output, but there are certain trails that you can do. And certain trails that are known. In fact, there's really only just one core trail, which kind of makes working with SHA-1 difficult, but...
So I just want to quickly, you say SHA-1, you don't say SHA-1?
I think I kind of say both at times, but
okay, I just find that.
I mean, at least right now, I'm definitely saying SHA-1 like I would MD5 or RSA.
Okay, fair enough.
So, I mean, although with the title Shambles, it kind of makes sense to say it, but nonetheless, oh no, I think I'm kind of fumbling over my words with this one just because it is a fairly complex topic to try and summarize. Said the presentation I linked to, it's YouTube. It has a good overview kind of the theory. And then the team right now is basically taking the complexity down a little bit further, using yet more complicated things that I just don't understand, neutral bits and boomerang attack. To essentially, cause this collision.
Yeah, so I'll be honest, I looked at the white paper and I kind of knew immediately when I looked at it. I'm like, yeah, this is not something I'm gonna be able to really read very well, because obviously when you're talking about crypto, it's very math focused. If you're not into that area, it can be very hard to read.
Very math focused, and the other thing is very SHA-1 specific. So, I guess also MD5. So there's a lot of overlap. They kind of use they're fundamentally similar.
Yeah.
So one of the questions in chat is, does this really cause much more damage than Google's 2017 SHA-1 collision? Yes. The key thing here is this is a chosen prefix collision, which I kind of talked about right at the start. When they're able to control, essentially, I'm not sure if they have the example here. Their example here is they're able to effectively break PGP, which essentially happens because you could, um, sorry, it essentially ends up happening just because you can control or you can collide basically with your own file. So you'll have one file that you want to collide with, and you'll have a file you want to have like a different value in the start, a chosen prefix, kind of where the name comes from. And from there, you're able to create this collision. So then you're able to use that against a lot more kind of practical real world attacks. With the 2017 SHA-1 collision, it was more of a, they could cause it, but I believe both PDF files had to start and end. So they had the same prefix and suffix, and then they had the collision in the middle.
Yeah, which we kind of covered.
Yeah, so it's fundamentally very different. It's a continuation from kind of like the same stuff. It's the natural kind of progression there. You go from having the collision to going for a chosen prefix collision. It's just the next step.
Yeah, I mean, the Google 2017 one that you mentioned, it's not really, on its own, it wasn't really that interesting because I think it was like just one case that they happened to hit. It wasn't really, something that, like you said, like they didn't really have control over the file contents very much. I think it was just kind of like a red flag, like, okay, this kind of indicates that we're going to see something like Shambles within the next
No.
couple of years kind of thing. And that's,
I wouldn't
that's what I was
entirely
thinking
agree with that. My reasoning on that just being that with the 2017 one, it was still like they still reduced the workload in order to be able to produce that PDF. Yes, it was still limited in being that they had to have the same prefix, but it wasn't like they just accidentally came across it. It was intentional. They still had some breaks in the math in order to reach that point, in order to reduce the complexity of getting that collision down. And I mean, I can give like, so what Shambles actually did here too, since I haven't mentioned it, is they dropped the complexity down to 2 to the power of 61.2 iterations of SHA-1 to kind of craft a block that works. Or several blocks, technically.
So one notable thing that we haven't mentioned yet with Shambles is they don't have the source code out for actually generating the attacks, just because they wanted to kind of get this out there and, get people off of using SHA-1 if they're actually using it. That being said, I don't think there's too many things really using SHA-1 anymore, seriously. But,
well, I mean,
there could
PGP,
be...
or, well, GNU PG is the obvious example that they went and broke. I mean, they talk about different places actually using it in the Q&A. Is SHA-1 really still used? And I mean, it's definitely dropped over the years, but it's still out there for sure.
Yeah. So they're holding off on releasing the source, so we can't really delve into that. And there is that factor that, it's not something you can really pull off on, like, in a CTF challenge on your, gaming PC. It does require quite a bit of processing power. That being said, it will come down more and more as stuff gets better. So, this is one of those things where it's going to become more powerful over time.
It still requires that 2 to the 62 or whatever value I said. That's still kind of the iterations that are necessary. That'll get cheaper to do, in theory, as things get better, but the actual computing necessary isn't dropping without finding yet further attacks or more optimizations that could be used.
Yeah. So the next thing that kind of came out was this Malwarebytes report, where the United States government-funded phones apparently come with pre-installed with unremovable malware. So
it sounds like a feature to me.
It's just a feature, yeah. So the phone that this article targets is the UMX U683CL phone, which I'll be honest, I hadn't even heard of before I read this article. But it's basically, as I understand it, it's basically like cheaper phones for people who are on the Lifeline Assistance Program. So this was a program that was started so that low-income people can have access to cell phones, right? So they're not going to be, as powerful as like the top end, your Samsung S8s and stuff like that. But they're good enough for people to be able to use who might not be able to afford some of those higher end phones. Um, so it's a government funded program, and they basically looked into it and they found, okay, this has a lot of sketchy stuff in it. And the first thing that they found was when they went into the notifications, there was this little like banner. I'm just gonna scroll down to it, and they highlight it with the red box, and it's kind of blank there. They have full in 9 minutes, and that's it. And the
Yeah, well, notice,
notification
yeah,
icon is
icon
blank
bar.
as well.
I love
Yeah,
that. I mean, that's just like,
not sketchy
you're
looking
doing
at all.
something that you shouldn't be when you have to try and hide the notification icon like that. I will mention that it sounds like Malwarebytes actually did this in response to a customer actually having one of these devices and filed a complaint, and then they went and bought the phone and started looking at it. I did think that was kind of an interesting move on their part. Like, it makes sense. I just thought that was kind of cool to see that they are doing that. I don't know if I have to assume other malware companies would do kind of something similar, but
Yeah,
I just thought it was interesting that they kind of, it seems to me like they went out of their way to really look into this one.
yeah. So that was a hidden ads variant, and then that wasn't the only issue. They had some other issues. There was another one. There was a wireless update app, uh, which is like an updater that it's fully capable of updating the mobile device, and they say it's the only way to update the OS of the phone. Um, and they found that it's a variant of AdUps, which is a Chinese company that's been found collecting user data and installing backdoors in the past without users' consent. So, that's a second one that's really
I mean,
sketchy.
and this one literally does start auto installing the moment you actually log in on the wireless update.
Yeah. And the third one was the settings app itself. Apparently, it had a dropper embedded in it for like other malware to be installed. So, there were just a lot of sketchy things. And
Yeah.
obviously, two of these things, the settings and the updater, are kind of critical to the phone. The
Well, so they
updater, they
actually
actually
recommend.
recommend
Yeah.
disabling. Yeah. They recommend disabling the updater entirely. They're like, yeah, you won't receive updates, but we kind of feel like it's worth the trade off.
Which is an
But the
interesting move. I mean, because no OS updates does also open you up to some issues. And I'll be honest, I agree with Malwarebytes on that. I do think in this case where they actively are doing something, I mean, who cares if you're being exposed to other holes? At least this active actor is kind of, well, I mean, they're still on your system probably, but it's at least reduced a bit, or the impact of it's at least reduced a bit.
Yeah. I mean, the worst one is probably the settings one, right? Because you can't remove the settings on a phone. That's kind of critical
Set it
to.
up how you want and then remove it.
Yeah, I guess. So yeah, like they're basically saying like this phone is just it's just kind of
Yeah, I mean,
a
don't
pile of
buy
crap,
this,
really.
obviously. I mean, that is kind of a very crap thing for them to do. I mean, settings app. I mean, this whole thing is, it definitely kind of rubs me the wrong way, just because, like, especially one, government funded. Two, I mean, focus on those that aren't going to be able to afford phones, or at least have some issue with that.
They're kind of
And
cornered into using like malware-ridden garbage.
I
You
would
know?
rather this be almost like Kindle Fire with like the ad version of it. Like, at least
Yeah.
that way, like, and I'm not saying I'd like that either, but at least it's upfront about it.
Yeah.
In this case, they're certainly selling your data. They're certainly invading your privacy. There's no overhead on that, and you don't know that's happening. So, like, oh no, it's. I hope we kind of get more out of this. Obviously, Malwarebytes is only really going to cover the malware, but oh no, I mean,
Yeah.
this is basically just backdooring somebody's phone. I mean, that's what
Yeah.
it is, from the point of sale, and I feel like there should be at least some laws about that if there aren't already.
Yeah, and I mean, I don't think it's much of a coincidence that pretty much every component that they found had like a backdoor or something like that in it was from a Chinese company, and the phone itself was manufactured in China. What I did find kind of interesting, though, uh, I'll say I'm surprised that they targeted this phone specifically, just because what do they really get out of targeting lower income people? Because when you're talking about trying to get like data mining for like ads and stuff like that, or like extracting people's browsing habits, let's say, and stuff like that for ads, lower income people are not like, it seems like a weird target demographic, I guess.
Well, it's not necessarily that they were even targeted specifically. It was, is because I mean, yeah, lower income people still spend money for one.
Oh, definitely, yeah.
Like I
They
don't
just
know
don't
who
spend
chose
as much
Target,
as
but
like other
well, I mean, are
demographics,
you
right?
only going to
Obviously.
target billionaires or something though? Either. Obviously that's just rhetorical, but I think part of it comes down to the opportunity was there. They want to have that information. They want to be able to collect it. And Samsung wasn't going to do it with their user base. Google probably wasn't going to do it with their user base. But these guys, they needed a little bit more money to make this affordable. Well, let's sell that data to somebody who wants it.
Yeah. So I think overall the article is a pretty good wake up call. I think it highlights that these kinds of attacks do exist. Obviously, over the years, we've heard about them and people talk about them, but we haven't. I don't think we've really had any great examples, and I think this is a really good example of just
But this is a
how
really
bad it can
blatant
get.
example.
Yeah, it's blatant, right? It's a good like showcase of here's what can happen. So I really like that part of the article. It's a good wake up call. So Mozilla had some security vulnerabilities also published this week. They had the advisory 2020-03. So they had a CVE 2019-17026, and this was a issue obviously in Firefox in the Ion Monkey engine, I think it was.
Yeah, it's
Um,
a type confusion in Ion Monkey. The interesting here, though, is less the issue itself. I mean, Firefox is a vulnerability. There's an update out already. Make sure you update Firefox auto updates. So, and as far as I'm aware, they're not automatically dropping malware on your system like the phone we just talked about is. But we don't really have the technical details on what exactly it was. But what I thought was interesting was that this company that announced this Kehoe. I'm not exactly sure how to say
yeah,
that.
I don't know.
Replying to chat there should be a patch. Yeah, like this is updated. There is a patch. I'm assuming you're talking about the Firefox thing here. This has been fixed. There's an update out. I think I just had mentioned that there's an update out. It's fixed in Firefox 22, it looks like. Anyway, the interesting though that I found was that they mentioned that, and this is that Kehoe or whatever. They mentioned that there was going to be a accompanying Internet Explorer vulnerability, and this was just in a tweet where they also mentioned this one. And I find it interesting. I'm curious if why they say accompanying. If it's just it was used in the same campaign that they saw this one in, or if it's actually a really similar issue across both, because obviously they're different engines.
Yeah. So just to like say something here, because I don't think we mentioned this at first. They do say that this attack has been found in the wild. Things in the wild abusing this flaw, which is obviously a pretty important thing to mention there.
Yeah, and I
Just
think
where you
the
were talking
Internet
about
Explorer
campaigns,
one
so I
was
just wanted
too.
to say that really quick. Yeah.
Yeah, no, I
Um,
forgot to mention that, but yeah, this was seen in the wild. Um, as for the technical details, though, and coming up in chat, mentioning there's a source code patch, there is. I haven't had a chance to look at it. I'm not sure if we can pull it up. I know the actual bug reference here is private.
yeah.
So can't. So I mean, we could probably find the actual commit if we dig through it a bit, but it's not something we usually do. unless the vulnerability is really interesting, or probably quite interesting.
Well, I mean, I will say type confusions usually are pretty fun, especially in the browser. Usually, type confusions are pretty much a guaranteed RCE.
Yeah, I mean, type
Um,
confusions are fun to exploit in general. I mean, they're just, I don't know, they're one of those things where, well, depends on kind of how it works out. But yeah, no, I agree. They're a fun issue.
yeah. One thing I will say though is like about like searching the commits and stuff, trying to find the source code level patch. A lot of these like security issues, they will actually try to hide and bury in commits. They won't reference the CVE usually. They'll kind of throw it in with other updates and they'll kind of hide it. You know that a
I
lot
don't
of the
know if
times they try to do
Firefox
that.
does that though.
I don't know
So
if they do, but they probably do, just because a lot of open source stuff does do that.
yeah, I
Um,
don't want to say Firefox probably does it. Like, I'm not aware of that. So I wouldn't want to make that claim that a company's going and hiding it without actually being certain about it. Yeah, some places definitely do that. I'm not disagreeing with you there. I don't know if Firefox does that, and I just haven't looked
yeah,
at
I just wanted
this
to
one.
mention that obviously they do that, and I think that's absolutely fair. Just to throw a cap on it, I do think that is fair, just because of the end day implications, especially on browsers. It's not too uncommon for people to not worry about keeping their browser up to date and stuff like that. So,
Yeah, at
um,
least browsers do auto update these days, though.
oh yeah, most of them do, unless you like you're like me and you leave your computer on for like 2 months and just leave browser windows open. But you know, browsers are typically pretty good in that regard. But yeah, maybe I will try to go searching just for details on that, just because browser bugs are pretty fun.
Could be fun
I
for a
usually have
stream.
be a fun stream. I was thinking. Um, yeah. So the next thing we have is the Citrix stuff. So that's
Or as it's been getting called by some people, Shitrix.
Shitrix. Yep.
That has been used by the media, so we're okay to say it.
Yep. So this was a vulnerability in the application delivery controller and Citrix gateway. So the issue was assigned CV 2019 19781, which has a 9.81 score, which is pretty fair, and you'll see why when we kind of cover the technical details of it. And it supports all the affected product versions, even newest, because no patches have shipped yet and won't until the end of the month, which is kind of the biggest part of the story, is that there's been some exploits dropped, or one specific exploit dropped for this issue
Yeah, and
before
this is
the
being
vulnerability could be
exploited
patched.
in the wild already too.
Yeah, absolutely. So the fixes for the products, they mention timelines here. Let me just see if I can find it on the page. 31st of January, 20th of January, 27th of January. So we're still like weeks out from seeing patches for this, and those are expected release dates. They could even be later than that. Um, so yeah, so the actual advisory itself was published on the 17th of December.
Just before you go there, I will mention they do have mitigations. So if you do actually manage some of these devices, there are mitigations you can go and fix. If you manage it, I'm sure you've already heard about this already. But they do have kind of like a way to prevent this from being exploited, which essentially just ends up blocking the incoming request to the endpoint that I'm sure Spectre will talk about here shortly. But there is a mitigation in place. It's not a patch though.
Yeah. So what I was saying there was just like it was published in the 17th of December, right? So that's pretty old. But what's new is that um, Project Zero India, which we will stress, like Z was saying to me at the beginning of the episode, was that's not the same as Google Project Zero. They're not, they're not the same or anything. But they actually dropped an exploit for this, which we also have open here. And it's a very trivial exploit because it's basically seems to just be like a path traversal issue. Um, so here's the POC open on the stream. If you're watching, you can see like, you know, it's just you can see over here. I don't know if it
Yeah,
scrolled to the
so
side on your screen. I don't think it did.
actually, I'll mention here. So what it is in the user preference module. It will build a path based off of the username that you provided. So you usually send in this NSC-user header, and it'll
Yeah.
build from that username. It'll build a path based on that. And then it'll go ahead and it'll write the preference is off or whatever. So you can do directory traversal, and that way you'll see in this proof of concept all the way over here. I think, okay, that's what you were trying to get at there?
I was trying to get over there, but I guess it didn't go through on your screen.
No, it didn't.
Yeah. So you can see right there, the slash dot dot slash dot dot slash. When you see that, you pretty much know what the what the bug type is. So the common weakness enumeration is 22, which is improper limitation of a path name to a restricted directory. So talking more meta about the issue, I don't know if I've seen a situation like this before where it's like publicly announced that there's an issue with a fix so far away and then an exploit drops for it. It's not something you see too often, I don't think.
I mean, this just comes down to this Project Zero India essentially being assholes. I mean, that's essentially what it is, in my opinion. Now, I can understand trying to get the details out. I think MDSEC kind of handled it in a decent way. I'm not sure if you saw their write-up. I'll pull it up here, but they did a little write-up about the same issue.
Okay, I didn't see that.
But what they did is what they've got, and I mean, this was just on the 10th here, so I'm not sure if it was before. Same day. They might have even did it after the Project Zero India one. But what they've got here, like their write-up, they give a lot of details here about some of the issues, but they leave out, and I won't walk through everything. They show kind of where some of the code issues are, but they don't actually give you everything you need to actually get code execution. They leave a little bit out. So, for all of those that are kind of taking this as a target of opportunity, they're not getting a ready-made Metasploit module. And yes, there is a Metasploit module for this already. You're not getting a ready-made script. It's not going to be taken by that until a patch is kind of out. And I don't know. I mean, I can understand for the person who finds the issue, they're kind of right to go ahead and disclose it when they want, regardless of actually informing the vendor. I have my own opinion on how that should be handled, but I can at least understand kind of the right of that individual to do so. I think it's another thing, though, how Project Zero India kind of went and handled this by releasing the exploit after. So there's the announcement, the advisory. They go and make their announcement about it, and then they go and release the exploit for it before a patch is actually ready. I can't really agree with that because they're not even the ones that originally found it. And yet they're the ones that are kind of dropping the ODay.
Yeah, I can see what you mean, where it'd be like a personal issue, but at the same time, it is kind of muddy when you're talking about dropping exploits. I mean, ultimately, either way, it is irresponsible disclosure to drop the exploit before it's patched. Especially because... So, I have another tweet, which I almost forgot about, that I wanted to bring up, because I think it has some relevant information here. It's just loading on the screen. So it's a tweet by Kevin Beaumont. He's actually pretty, well known in like the InfoSec area. So he was saying there's about 3 times as many Citrix SSL VPN boxes than PulseSecure ones. So there's hundreds in US government sites and thousands for MSPs. They've also been getting actively scanned all week, and with the exploit, you can backdoor the box so you can maintain access even after patch. So that kind of highlights why it's such an irresponsible disclosure. Just because the issue is so, when you get a shell, it's not hard to plant a backdoor. So, and
no, I mean,
where the issue isn't patched, it just kind of highlights some of the impact of dropping an exploit like that.
And I mean, this Project Zero India also dropped the PulseSecure vulnerability. I'm pretty sure we talked about that on another episode, but one of their only other repository just happens to also be for PulseSecure SSL VPN. And I think we might have talked about that again. I don't know what episode it was on, but just since Pulse gets mentioned there too, and I don't know how that disclosure went. It might not have been kind of like this one, but yeah, it definitely kind of rubs me the wrong way in terms of how they did that disclosure. One question of chat from Mick Swagum is responsible disclosure illegal? No. or sorry, is irresponsible disclosure illegal? I think I
Is
said. I think I said.
disclosure illegal?
Yeah. So is irresponsible disclosure illegal? And no. Generally speaking, it's going to be protected under free speech. That said, there probably, so as far as I know, there have been no cases of it being followed up in court. And I'm just going to speak mostly like thinking about Europe and like Canada, US. I'm not thinking about, necessarily every country out there. I suppose it would be illegal, like I think China maybe has a few more restrictions on just disclosures in general too. So I don't know everything about all the laws everywhere. So I'll say, but
How dare you?
generally speaking, it is protected as like a free speech sort of situation. Though I'm also kind of thinking of all the case of, writing malware. The difference being that writing up the exploit script is usually kind of sent as wild dual use, whereas writing malware,
It's only malicious.
yeah, if you can write your malware in such a way that it isn't at least presented as only malicious, like a remote access tool versus a remote access Trojan. Yeah, kind of the difference between those is very subtle, but it is there, and one of them then is dual use, and will be very hard to have any case made, and the other one, essentially, you're aiding criminal actions, or you have a reason to believe that it will be used criminal action. So as far as I'm aware, irresponsible disclosure is not illegal.
That being said, do you think it should be? See, I don't think it should be, but I'm just wondering about you because I know you have some differing opinions from me on disclosure.
Yeah, and definitely not illegal to just, disclose vulnerabilities. I don't think that.
Okay. Like, I just wanted to get a bit of an idea of what your stance is just on. Like, I know you don't like irresponsible disclosures like this personally, but I know, like, you're also a bit on the fence when it comes to disclosing fully, even after patch, right?
Yeah, so I think we'll talk about that in the next topic, but I want to jump back super quickly, and
Okay.
actually just say that, man, yeah, I'm still not going to say your name, out of chat. I think I was having trouble saying it last time too. I actually found a tweet here about Firefox faking a commit date in order to try and hide this patch for this CVE.
Well, now we know.
So now it becomes more interesting to look at because they tried to hide it.
Yeah.
Oh, this is your own tweet too. So a little, I'm assuming at least since I see the last names there. So
there you go.
You get a little shout out to all 7 viewers we've got.
Yeah.
So jumping back though to your question, I think we'll talk about the disclosure a little bit. I mean, might as well go right to it actually, which is Project Zero made some changes to their disclosure policy. Fairly straightforward changes, but significant too. So I think a lot of us are going to be familiar with their existing policy where companies have 90 days to fix a bug, and then the report gets opened at the researcher's discretion, which usually means like if it gets patched, patches out there, the researcher can go ahead and just open the bug report up so everybody can kind of know about it. The new policy though is 90 days, and then the report never gets and then the report's open. The researcher doesn't get to open it early unless there's a mutual agreement to have it open early. And they've made some changes into incomplete fixes are always going to be added to the original report instead of getting new reports and some other changes like that. But the key thing there being that it's always going to be 90 days. The exception to the rule might be that they'll open it later. And
they do have a
open it
period,
sorry
I think.
Yeah, they have a 14-day grace period, but the gist of it is like that 90 days is always going to be there even if it's already patched is what I meant to say. Rather than later, I meant to say if it's patched earlier. But yeah, so they do have a grace period for like the 90 to 104 days where they can, but then it becomes basically as soon as it's patched, the report becomes public. Um, their write up here though, or their blog post, kind of talks a lot about their rationale for this. It simplifies kind of what they're doing. They talk about what they're going for: simple, consistent, and fair. Basically, it does exactly that. It does encourage, I think, the incomplete fixes to be dealt with a bit more often.
Yeah,
Or
so
sorry, a
it's
bit better.
yeah, it seems their main goals is like trying to push faster patch development and more thorough patch development. That's like their big things that they have highlighted there. It's kind of interesting just because it's different, but it's not necessarily like reports are gonna get out earlier, right?
Yeah, I mean,
Because
reports aren't getting out earlier, but this does kind of create the.
it adds some pressure basically on whoever they're
Yes.
reporting to. Just because in 2019 they could be opened by the researcher at the discretion after the deadline expires. In 2020 it's open automatically on day 90 or earlier, so it's not going to be later than day 90 unless they ask for that like extension period.
Which is
And if it
just
is patched,
14 days, too. I mean,
yeah,
that isn't very long. When you're talking about a 90-day thing, it's like, yeah, okay, you get another 14 days to get it out.
yeah, and even if it is patched in that 14-day period, it's opened immediately when it's patched. So they're adding a bit more pressure on companies.
Yeah, it's definitely an interesting move. Like I said, it simplifies things. The one that I find most interesting, I mean, with that, though, is just the incomplete fix aspect. What this
Yeah,
will allow is for them to maybe get a little bit more focus on having those incomplete fixes actually looked at, like taking that time rather than, okay, the patch is out, let's get the report open. Oh, their patch actually isn't good. Having, in theory, things are going to get patched before the 90 days. Apparently, their numbers are some like 97.7% of issues are fixed and under the deadline.
that's pretty
Issues that
good.
they report, yeah, their numbers are super high compared to what I'd have expected.
I will say there's a bit of a caveat to that though, just because Project Zero, bulk of their reports end up going to Apple. It's almost all iOS and WebKit. So because of that, there is a bit more of a relationship between P0 and Apple, whereas when you're
Yeah, and I
talking about
mean, even
disclosing
just
other
the type
vendors, there
of
might not
issues
be
they
as much of a
find,
relationship.
who they're looking at, and all of that. Like, it makes sense that they've got a higher number. I'm just saying it is higher than I'd have expected it to be. I mean, there might be
Oh yeah,
some biases in that, but it's still higher. But dropping back there, the incomplete fix I think is a really important point because oftentimes things do get fixed. People think it's fixed, and then there's some little edge case that they overlooked. And I think this will help companies with that. Like, I definitely think it's a positive move for Google to make this change.
and I think that's also more relevant just because I'm pretty sure some iOS issues I've seen reported in the past had this exact issue where there were multiple CVEs and reports opened for basically the same bug, just different ways to reach it. So, focusing more on those incomplete fixes, it that's probably the most interesting detail for me as well. Just because of that aspect where it is something I've seen before, I'm pretty sure for iOS.
Yeah.
Which is obviously P0's biggest, area that they look at, maybe other than WebKit. So, yeah.
Yeah, so I actually didn't know that was their biggest area that they looked at. I haven't really looked at their entire listing to see that, but
I'm pretty sure like Chromium or WebKit is like their big thing, but iOS is like probably a close second. They do a lot with iOS.
yeah, I mean it makes sense on why they're looking at that, and I don't see them coming out with like Apache or Nginx, O days. I can't think of any. Maybe they have, but I can't think of any. So I mean, I could understand why what they're looking at is also at least tangentially related to what Google is doing. That said, I do want to tie this back to their last topic of that Project Zero India and their disclosure and just kind of disclosure in general. Um, so you would ask me a question, and I probably should remember since it was just a few minutes ago. But do you remember it?
It was basically just like what's your stance on like full disclosure in general, especially when you're talking about like even like after the bug is fixed. I know you're kind of you don't
Yeah.
really like full disclosure even after patch. So I just wanted to talk about that a bit.
Yeah, so I mean, I've got to balance that a little bit. My personal take on disclosure has generally been non-disclosure, except by the vendor. Um, I've definitely been moving and changing that a bit, but that's kind of, for a while, that's been my view. Vendor disclosure, essentially. Of course, a lot of vendors just aren't going to deal with it. They're just going to take the report and ignore it, whatever. Uh, that said, I want to say that's been my personal take. I don't actually, despite it being my personal take or personal mode of operation, it's not necessarily what I think is the best move. Like, I think the threat of full disclosure needs to be there regardless. And I think this deadline based disclosure that Project Zero does kind of does that. It adds the threat of the full disclosure. It is full disclosure after that. Oh no, it balances a lot of things. So I do like how Project Zero is handling it. On like a very personal level, though. Oh no, maybe it's just because I remember, people getting arrested for reporting issues back when I was younger. So I just, it's one of those things that I'll say, just generally try not to be disclosing the vulnerabilities publicly and let the vendor do that, but I don't think that's the only way to go about it. I guess I'll also mention there it is answering chat from Mixwagum again. What do you mean arrested for reporting issues like disclose a vault and got arrested? Basically, yeah. Yeah, in the late 90s, early 2000s, there were a lot more concerns about exactly how to handle reports. Now, to be fair, there was also a lot more illegal activity going on when it came to testing. Nowadays, I mean, you could spin up a VM, you can go run whatever software you want and go ahead and test it. You had kind of like now you've got a lot of avenues for the legal testing, especially as you're learning and stuff. Back then, at least to me, it felt different. Maybe that was, as I'm in my teens or whatever, I just felt rebellious and, it wasn't actually that common, but yeah, there definitely were people though who may report a vulnerability, especially because early mid 2000s, tons of web issues. So you're necessarily causing unauthorized requests to the server. Whether or not they actually had the charges go through, I can't say. I mean, a lot of these people were people I knew online, not didn't know their names. I just know somebody's been banned or whatever.
VN, yeah. Um, yeah, I mean, the biggest issue when you're talking about like full disclosure after patch is like the end day attack scenario, right? Um,
Yeah, and I mean that's kind of a common mention as well. If you fully disclose it, it doesn't endanger users, and I think that also is a really important aspect to it. Where a lot of issues even back then were like single issues. You have this exploit, it's all you need. Whereas a lot of the stuff that like Project Zero is putting out, it's a single step in a chain of exploits. Like you looked at the bad binder exploit on Android, and
yeah,
with that one, I mean it's a single step in the chain. You still need your ASLR bypass for that. You're still going to want um some means of getting persistence, I think, after that. Like, there's still more, and you need to get somewhere. Bad binder needed local code execution, so you're going to need to get to that point.
yeah,
Like, so a lot of issues now are also multi-stage, and a lot of vulnerability reports only really have one stage in them. And
yeah.
I think that's an important distinction too, just on how vulnerabilities have gotten more complicated. Um, that does make a difference. Oh, I'm going to be honest, like my views on disclosure have definitely been changed. Actually, even just in doing the bit of research for talking about this, Google has a good little FAQ on their opinions. I don't have the link, and I'm not sure if it's linked in this one.
Yeah. Okay. What I was gonna get into though is like the big worry with like full disclosure after things are out is the end day scenario, and I think it's more on the vendors to protect against those scenarios. Um, I don't know. I mean, I what I'm trying to get at is I don't think it should be the researchers. Like, I don't think they should be prevented from talking about something they found that they want to, they found cool and wanted to talk about just because people don't want to update or the vendor doesn't have like an auto update or something like that. You know what I mean? Like, I think it's unfair to lay that at the researcher's doorstep, which is why I'm
I mean, at
more
that
towards full
point,
disclosure.
well, just to be clear, full disclosure is actually a very specific thing, and I don't think it's actually what you support. Do you support, you find an issue, you go ahead and drop everything right then and there, or do you support responsible disclosure?
Okay, sorry, responsible disclosure. I mean,
Okay.
like,
So, because full disclosure actually, like, good old Project Mayhem and stuff. So, like, there's definitely a history with full disclosure, and, we're definitely talking about full disclosure after, like, fully disclosing a vulnerability after things have been patched, after there's been some coordination with the vendor, after a deadline, after something. I
yeah,
just wanted to clarify that.
yeah. But like, I lean more towards disclosure than you do, I think. Although I don't know, you kind of changed, so I don't know if we're kind of equal on that. But yeah, I
I
just
mean,
thought
my
it would be
thing is,
something interesting to talk
I'm
about anyway.
totally okay with people that want to disclose and have work with the vendor, do their own disclosure because, like I said, it's cool. You want to add to the knowledge of kind of like everybody by releasing that information. I don't take issue with that. Like, it's not like I'm against that. I just personally like my own personal habit is essentially a non-disclosure type thing.
Okay.
And like I said, like my views on that are actively changing, especially the last couple of years. But that has kind of been my take.
Yeah, yeah, I think that's fair. Okay, so jumping into some exploits, we were talking about some iOS stuff regarding P0, and somebody who's fairly notable in the iOS scene, Sagusa, put out a blog post on PAN, or Privileged Access Never. So for those of you who work more in x86, which is probably more common, this is basically the exact same thing as SMAP, or Supervisor Mode Access Prevention. So Privileged Access Never basically means in kernel context, you can't read directly userland memory without going through some like special API function in the kernel that there's like special instructions that'll temporarily disable PAN and then re-enable it after you've gotten what you wanted. Because obviously from kernel you will need to occasionally access userland memory in legitimate cases. But the whole idea of PAN is basically making it so if you're writing an exploit and you want to fake a kernel object or want to write a ROP chain or something like that, you have to get it in the kernel. You can't just use userland memory to do that, which is actually it's quite an effective mitigation. To be quite honest, it's a real pain in the ass to get around. You basically need like a really strong info leak to get around it in many cases. At least when you're talking about like code execution. But this article actually goes into how they actually broke it through a feature that was implemented in the kernel. And there were actually a few kernels that implemented this. They talk about Linux kernel, but obviously iOS kernel did it as well. Um, so he found it back in October of 2018 when he was working on Spice, which I think was a jailbreak that he was working on with Lalo and Sparky. And so I'll just go over the commit message that's mentioned here. So ARM64 revert support for execute-only user mappings. So the ARM v8 architecture supports execute-only user permissions by clearing the PTE user and PTE UXN bits, making it like a privileged mapping, but somebody from EL0, which is like the lowest privilege level, can still execute. So that's basically, they added support for people to be able to map execute-only pages. And execute-only memory is useful for like, if you want to have code that's executable but you can't dump it, it's useful for trying to keep like, it's mostly for like firmware and stuff, trying to keep it closed source. But yeah, they wanted to add support to that for userland. But it just so happened that when kernel ended up trying to access execute only user mappings, the privileged access never was actually never checked. So you could stick data or code or whatever in the execute only user mapping, and then bypass pan completely. So if you get code execution in the kernel, you can just jump to a payload that's in that mapping, and you don't have to worry about pan at all. So
Yeah,
it's
and
not a super long write up. Sorry,
I'm
what were you
just
going to
I
say?
was just going to add, so you're saying it's not super long write up. I mean, this is a really simple issue when they look the code, like in terms of what happened there and stuff.
Yeah,
I
it's
was
more
just
of a
going to say,
design
like,
flaw than a technical bug.
well, I mean, it's almost just a logic, like it's just writing the conditional.
Yeah.
But yeah, I don't know. I just thought for like such a high impact, like defeating pan essentially. Yeah, it's a really easy to understand issue.
Yeah,
Go
it's
ahead.
very straightforward. And these it's awesome to see mitigation bypasses because you don't really see them too often anymore. Usually, in terms of mitigation bypassing and exploits, you usually do that just with another bug, trying to get more and more information out of the process address space through like an info leak, for example. But it's not often you see something that directly bypasses the mitigation like this. So it's really cool. I do want to say I saw some people saying that the title or whatever is a little bit clickbaity, just in the sense that it makes it sound like another day, another broken mitigation. It makes it sound like pan itself is broken. This is more just like a way that they found to get around it. Features that didn't consider it, I guess. So, it's not that like privileged access never in itself is like inherently flawed. It's just that there was, this piece of code that never actually checked it. But like, this is a really good write up, and I really liked it just because it was so straightforward. And usually when you talk about stuff with iOS, I mean, this is kind of divorced from iOS. It's not specific to it because it talks about Linux had a similar issue and stuff like that. But usually when you're talking about Apple stuff, the write-ups are a little bit harder to access, right? Because there's like lingo and stuff associated with Apple that you might not know if you're not familiar with that scene. But this write-up was like very easy to follow. Like you said, it was a straightforward issue, and it's just really cool. So yeah, I really want to give like a props to this write-up. I think it was awesome.
Yeah, I completely agree.
Yeah. So, if you're looking to bypass iOS pan, go ahead. I did want to say, actually, it was patched, I want to say iOS 12.3, but I actually don't have it written down for some reason. Let me just... I can't find the version, actually. It might be 12.3, though. But there is, it's obviously been patched. But if you're under an iOS version, you could play around with it if you wanted to. Yeah. So we'll move on to the next topic, which is TikTok. So this was pretty crazy of a story. So we'll do an overview of it, and then we'll give some thoughts. I think they'll be pretty negative. So
Well, actually,
TikTok.
before we go quite into the overview, I do want to mention, the title here, TikTok, is TikTok secure enough? It's a Chinese company.
Yeah,
China has definitely, we know they will coerce companies to put in backdoors and things like that. So no, like simple answer, no. That said, there are a lot of other issues here, as
yeah,
Spectre, I'll let you cover.
yeah. So TikTok, I'm a bit of a boomer when it comes to these apps. I've never used it. I've never downloaded it. I probably never will. But it seems
You
to be
don't
kind of
like
like
lip
a...
syncing?
No, no, I'm not
Oh.
into that. But it seems to be kind of like a Vine kind of thing, like short videos, like you were saying. Like I think lip syncing is popular on it, or maybe that's the entire purpose of the app. I don't know. But I'm not going to download it to find out, especially because, like you were saying, there's already been controversy about TikTok in the past. I'm pretty sure there was a story recently where they actually did give data to like the government about the Hong Kong stuff or something. There was some political story around it. So, there's already been controversy around just the meta of TikTok, not even talking about it from, a vulnerability and security angle. So, this article talks more about the vulnerabilities and stuff, which kind of compounds on top of that. So they found multiple vulnerabilities in TikTok, and they have like the section on all the technical details. So the first one was a SMS link spoofing issue. They found that on the main site, there's a functionality to let users send a text message to themselves in order to download the application. But the problem is in the what the download URL that is sent, as well as the number that sent it to, is directly in the HTTP request. So you can basically use this to send text messages from TikTok containing arbitrary download links, which is just I
Yeah,
don't really know.
I mean, this is. I mean, so the mobile number, okay, you're submitting your number for them to send you the download link. Makes sense. I get that. I don't get why the download link should even be in there. Like, I don't get what they were trying there. Like, I mean, at the very least, if they had to try and do some like detection on the system, I'd say, make a single page that does, link people to that, and then it does feature detection and, forwards them to whatever I want. But I mean, they're not doing that on the browser. So like, it seems like this is almost a constant, or going to be a constant download link they should be sending.
I don't know why they don't just have it hard coded. It's
I mean, the only thing is, if it was localized, but still, like, you send, the localization to use. Although it does, I see in the request there, it actually does say the region. So, I don't know. I mean, this one, it's just like, why? Why include the link right there? Like, I don't see the decision for that. There's so many easy ways to just not do it. I mean,
yeah, I know.
The number spoofing is kind of another issue. Sorry, not number spoofing, but like sending a text message to any number. I don't know if they're rate limiting this or anything. It doesn't seem like it. And looking at the picture, I mean, it's not like there's a captcha. I mean, maybe there's a hidden captcha. Maybe there's something. I don't see anything being sent along with this that would indicate there's any sort of, captcha involved or something. So, I mean, no actual verification or no actual work needing to be done to abuse that. So, I mean, it's basically free texting, too.
Yeah, I wonder if they did explore the text bombing angle. I didn't see anything about it, but I mean, that's absolutely a fair point. Is that, yeah, just overall, just like a really weird interface entirely. So the next issue, like that one's pretty trivial, and you can see.
I think all of these are pretty trivial.
You're right. The next one is when they were reversing the app for Android, they found it has a deep links functionality. So basically, they can specify a bunch of intents to have like prefixes for the domain for the schema. So you can have like they give an example musically : / and they have like a bunch of these. And combining it with the spoofing, you can send a custom link that has those schemas, and apparently one of them will actually open a new web view and go to a attacker-controlled page, and those requests are sent with user cookies. So,
well, so I mean, cookies are just like they are actually logged in when they make that. It's not like you're getting TikTok's cookies. So in their example here, they have a web view, URL equals, and it's going to 10.10.10.113. It's not like that 10.10. Like the attacker controlled website, if they're going on another domain, is getting like the TikTok cookies. But the web view itself, it has like they're logged in on it.
Yeah.
At least as far as I know, I haven't actually tested that, but as far as I know, it shouldn't be sending those cookies. But it does mention that any requests will be sent with user code. So maybe it is doing something a little bit weird with that.
Well, they mentioned that
because they do mention it.
Yeah.
Like, so they do mention, any requests will be sent with user cookies, but as far as I'm aware, you're still needing to deal with like the same origin policy type stuff.
I wonder about that, because didn't they actually mention CSRF somewhere in here?
But that's later.
Okay.
They do JSON-P, which lets you basically can ignore CSRF. Sorry, they do JSON-P, so you can ignore same origin policy.
Yeah.
But yeah, I mean, with this one though, again, why just let a random URL be low into your web view? Because this also has, I don't think they mentioned it, but this is something that I've seen done actually in Discord. With like Discord desktop application, mobile application, somebody has a breakout on the link or whatever, so they can get it to load just any random page. So you can use that for like phishing to make it load the login page again, except it's actually your attacker controlled page. In this case, it's just a super simple way to load up any URL right inside the application, because any page they're seeing, they see this is inside the TikTok application.
Yeah.
It's from TikTok. They don't necessarily see the URL bar. It's just the web view.
Yeah.
So they don't necessarily know, where it's going. Which is, I think, another part of this issue that they just don't mention.
Yeah. And, speaking of like the, URLs and stuff like that, there's another issue that deals with something similar, which is open redirection with domain regex bypass. So this is an issue where the login request page actually has a get parameter for a redirect URL, which is yet another thing where it's kind of like, why exactly do you have that?
So this one's kind of common. So what happens there is, say you try and access, I also don't use TikTok. Let's just say they have like an account settings page. Or actually, better yet, let's say they have private profiles. So like, I have a profile, but you can only view it if you're my friend. So we're friends, so you know what my profile is. You try and access that, but you're not logged in. So it'll send you to the login with the redirect URL set to redirect you to my profile once you log in.
Right.
So that's why it has a redirect URL there. And obviously they have many kind of subdomains and stuff. As for so the functionality itself, like a redirect URL, isn't exactly uncommon. And actually, it's not all that uncommon to not have it protected. So I mean, at least in this case, TikTok tried to make it so it's only redirecting to their own domain. It's just they didn't quite do that validation well. I'm sorry, it sounded like you're going to say something about like why.
Well, I was just gonna say, like, usually when you handle stuff like that, though, don't you just handle it from like the HTTP refer from like the server side?
Well, you don't have it anymore though. Because you're going from, I mean, one, that also, like, a lot of people will strip that out. Browsers might strip that out. You just might not get whatever.
Okay, it's true.
There's that, but I mean, at this point though, you're going from your attempt to access profile, you're being redirected to the login page. So that login page is going to see your refer to kind of know that. And actually, I guess that's a fair point now that I'm walking through it there, that of course it should in theory be able to read it, but no. The simple answer is no. I think a lot of cases just don't actually look at the refer header because it isn't terribly consistent. Same deal with the origin header. They're not too consistent, and there are a lot of cases for wanting to redirect somebody elsewhere from just where they came from.
Okay.
So I can at least understand why this feature exists. And they tried to protect it to only go TikTok, but the issue is they basically just made sure the domain ends with tiktok.com.
Yeah, so you can register a domain with any prefix and it'll verify and work. So didn't really think that one through. I wonder why they did add that like wildcard specifier in the regex.
Well, I mean, they obviously have like multiple subdomains.
Yeah, the subdomains. Yeah, that's right. That's
like login.tiktok
that for a second there. Yeah. So yeah. This one I think is more forgivable than pretty much all the other issues.
Just yeah, I mean, it's just bad regex. And I mean, regex is hard at times.
Yeah. The next issue was cross-site scripting. They found the ads.tiktok.com site, which is apparently like it has like a portal for you to be able to submit help and like tickets and stuff for how to publish ads in TikTok. So they have a help center, and it has a search functionality, and you can probably, search functionality XSS. You already know what's going on. The search page, there's an XSS right in it. So,
well, like there's nothing here. It's you inject your script tag and you've got your execution. Like this isn't even pretending to be something. I mean, sure, they have to do the breakout with the single quote. I guess I never actually confirmed they had to do that, but this shouldn't still be an issue. Just, I mean, I know there's a lot of hate for like Angular and for React and Vue and Svelte and whatever else
billion frameworks.
But those frameworks do one thing well, and that is XSS attacks are a lot less common because of them, because they understand they're handling an input value and you want to display it, and it's not HTML, and you have to kind of do extra steps to get HTML in there.
Yeah, I mean, XSS at this point, like you were saying, it should be pretty much dead.
And I mean, people know how to handle it otherwise too, but I'm just saying, like, there are a ton of frameworks. And I mean, it's not like TikTok is necessarily needing to aim to be the lightest weight thing. And it doesn't, I'm going to bet there are other issues too. Like,
oh, probably.
Because I mean, this is such a simple and obvious attack point.
Yeah.
That's like, if you miss this one, you've almost certainly missed elsewhere, or it's just terribly unlikely, but I don't find that likely.
Yeah, this is one of those red flag articles where it's like there's so many low-hanging fruit issues that there's no possible way that there's like other things that are totally secure. Like there's probably so many more issues yet to be discovered.
I mean just the XSS. Like there's got to be more.
Yeah.
I mean, maybe not more that are super useful, if depending on where they're hidden, and obviously there's a whole application, but I mean, it's like, because that is just such a simple cross-site scripting. It's not something that people should, it's not a mistake that should be happening anymore.
Yeah. So after detailing all the bugs, they talk about some of the actions they could perform on behalf of the user.
Well, this is still an issue. Like, cross-site request forgery is another bug. They don't do any, like, they don't have any anti-CSRF tokens. So, like, this is still another issue. And with that, it's just, yeah. So, essentially, cross-site request forgery. No CSRF tokens. Basically, all of these, the gist of it is all of these requests are repeatable. You can go, and if you had the request in your browser, you can go hit F5 and it'll do the same action over again. Or you can change some values in it and kind of do it again on another user, trick them into doing it, which is kind of the key for exploiting CSRF. Is you're usually going to try and create a request that would do something when another user makes that request. So their example here is deleting a video. It's just, get me view blah blah blah, just get delete, and it includes a video ID. That's all it is. Oh yeah, they have more.
They can take.
But so, this one here, if I can just explain what CSRF is though. This one right here though is, they just provide the ID. So if you want to attack somebody with this, you'd maybe create your own really cool cat website, and you'd include an image on it that goes to that URL. And then when somebody visits it, they go to that URL. So if you have a friend, they've got a video you really want them to delete, and you get the ID. I assume the IDs are maybe not visible, but like readily seen. They're usually not hidden. So the ID, you would craft kind of that little image. You just put that little image there. It's not going to load, but the request will go through. Mm-hmm. So from there, you include that. You just trick them into visiting the page, and suddenly that video is deleted, because that's all you need to do to delete something. So usually you'd want to, make that a post, which doesn't fix it. You can still make post requests. Like, you can use JavaScript to submit a post form, set the target to an iframe so it doesn't actually change the page. And you can, being post doesn't, but like generally speaking, get just shouldn't do anything stateful. But the other thing is you'd want to include some unique ID that's like authenticating that the request actually came from the user. Something unique that an attacker wouldn't know or wouldn't be able to craft ahead of time. So yeah, they basically found that they're lacking any sort of CSRF checks on what only seems to me like everything.
Yeah.
Delete, create videos, make a video public and private, following people. I think that's everything actually that they mentioned. Become a follower.
They mentioned being able to like manipulate account details and reveal personal information and stuff. Like pretty much anything you can think. Like pretty much. So
sensitive data is actually another issue.
Okay, I thought that was actually exposed through the same issue. So maybe
no. So this is it kind of sorta. Um, you can do this again with CSRF, but part of the issue here is just that basically they're using JSON-P, which is JSON with padding, which means that you don't have to deal with. You basically just specify like kind of the case where this would be used, like just as a general rule, is an API, which is exactly where TikTok's using this. Is it's an API. Most of the time, though, you'd have some sort of API token, something unique per the user, so somebody couldn't just create a random request and cause you to make it. But with JSON-P, the idea is you want to include like a script tag that loads some JSON data from some data source. So an API makes sense for that. You include your script tag, and just in the URL or as part of the request, you'll include a callback method. So then that script that you're including, it'll kind of generate a page that calls that function with all of the data that it actually has for you. So that's how it's kind of able to get information back. Where it relates to CSRF, though, is the fact that like there's nothing unique here. If you make this request, it'll use like whatever user's currently active is. It's essentially CSRF again. So it's that, but specifically with this JSON-P API.
Yeah. So
they actually have the example here. The data that comes back, there's the script containing my callback method, and then all the JSON that they can extract. It's kind of in the screenshot there. But yeah, and also pulling out a lot of information there. Like, there's a ton of just really simple issues.
Yeah, so a lot of low-hanging fruit issues. Doesn't seem to be really designed with security in mind at all. So overall, like with TikTok, you had the issues on like the political end, and now you also, with this article, it exposes how terrible it is on the security end. So overall, I don't think I'm going to be installing TikTok anytime soon. I wasn't already, but now I'm like definitely not.
I don't know. I mean, I kind of want to install it just to look for cross-site scripting in the intent handlers. I just, as we were talking about, that kind of seemed like an interesting tax, especially since they probably have some low-hanging fruit there. Might be
get a bunch of
interesting to look at
CVEs.
Well, I don't know, just
for fun, yeah. I know.
Yeah, I don't know. As we're reading it, that just kind of stood out to me as something that might be fun to look at, cross-site scripting within the app. I'm assuming, actually, I'm saying cross-site scripting in the app. I have no idea what this is built in. I'm thinking of it like a React app sort of thing. But actually, I realized that's probably a really stupid thing to say here. Yeah, not going to be cross-site scripting, but I don't know. There should be some other low-hanging fruit that I might want to look at. Oh no, like I said, I remember the Discord one, which cross-site scripting in Discord's kind of doable because of it being an Electron app. Yeah. I was kind of thinking the same thing here at TikTok, but it's not. I'm almost certain it's not going to be that sort of app. Just given what it does, I can see it being that. I don't know, but yeah, that was maybe a stupid comment from me.
That's all good, but it could be fun to look into. I got what you were trying to go for there. So another disclosure that happened, I just accidentally messed up my page there, was Fortinet. They have a product called FortiSIEM, which I think is Security Information and Event Management. And their system had a hard-coded SSH key for a user called Tunnel User, which is the same across all installs. So another, just adding on to our low-hanging fruit section, I guess.
Yeah, well, I guess last time... not last time, episode 20, we talked about Fortinet using a hard-coded XOR key to be sending data back. This time, it's just a hard-coded SSH key used by this tunnel user. And the tunnel user essentially just lets you create a tunnel from, localhost to the actual supervisor. I mean, there's not much more to say about it. Hard-coded key that every system uses. Go ahead.
Yeah, and I was just gonna say, like, they mentioned that it's like stored unencrypted in the image, so that's not too hard to get either.
I mean, that's if it needs to be accessed, though, like I'm assuming it's used by some sort of service thing, like there's no way you're protecting that either. So I don't think adding encryption to that key would have helped. I
Okay.
think the better thing would be generating a new key,
absolutely.
but at the same
Yeah.
time, I don't quite know how this gets used exactly. So I can't really give any remediation information, but the fact that it's unencrypted doesn't make a huge difference to me because it's probably not being used by like a user. It's not like like I mean it lets you get access as though it was, but like it's not my personal SSH key where I'd have it, encrypted and I type that every time. You're not going to have your daemon typing the password every time. Um, Obviously there are kind of ways to implement that, but depending on how this is used, I mean, it's just kind of another layer. Okay, so you grab the hard-coded key that's used to decrypt the key.
Yeah.
There. So, I don't know. Without knowing more, the fact that it's unencrypted isn't too much of an issue to me.
Yeah. I just found it interesting. I'm not saying that was like the core of the issue. I just wanted to say that I found that interesting.
Yeah.
So yeah, pretty trivial issue. Not too much technical information to go into there. I think it's pretty ironic though that they have such a low-hanging fruit issue in a product that's called Security Information and Event Management System.
Yeah, I
So,
will also say,
bit
actually,
of
I
irony there.
thought it was interesting. They disclosed this one after 30 days because Fortinet basically just didn't reply to them. Looking at the timeline here, it's email sent to Fortinet on December 2nd, automated reply on the 3rd, on the 23rd, sent a reminder, and on the 3rd they publicly released that, stating that they would give like a 90-day if they received at least some confirmation.
Yeah.
And I don't know. I mean, given the other issues we've seen from Fortinet, or I'm not, or I guess, yeah, Fortinet. I'm not surprised. They don't seem like a
They don't seem to
company
care
I
about security,
I want to
I guess.
trust too much. Maybe it's just a bias because of how we've been exposed to them.
Yeah.
But I mean, it's definitely bad handling. Like there should be some response inside of 30 days. Like
Oh yeah, definitely.
something.
Especially considering it's not like a very technical issue like we were saying. It's a very high level issue. It shouldn't be hard to like
No, I
at
mean even a
least
courtesy
address.
response saying, won't fix.
Yeah.
Because
Won't fix.
they decided that, they just need this tunnel there, maybe how this is set up. It's like there are reasons for not fixing it. At least giving that explanation. The lack of it, is concerning.
So something we can get a bit more technical on is another Project Zero blog post that was put out on the remote iPhone exploitation, which is poking memory through iMessage through CVE 2019-8641. So this was posted by Samuel Grobe. I want to say that's probably not the right way to announce it because it's like I think it's like a German B or I don't know what that is. I don't want to say it's like something it's not. But he's more commonly known as Salo or 5alo. He's the one who published that paper attacking JavaScript engines, which I've talked about in the past. He's a really talented guy. He focuses a lot on browser, but in this article, he actually focuses on iMessage in iOS. So this is the first part of a 3-part blog series. Now, I will say the second and third parts actually are out. They were published on the same day of January 9th. I haven't really gotten a chance to read the other 2 parts, though, because they're the other 2 parts. So I'll say what each part's first of all. So the first part covers the CVE that I just mentioned in iMessage. The second part covers an info leak used to get more information on the process layout. And then the third part covers getting code execution from JavaScript and returning to userland. And they talk about like some ways you can get around like pointer authentication or PAC and stuff like that. But this first article is what I mostly read. The other 2 I haven't really got a chance to because there is a bit of a higher prerequisite to reading them just because they're a bit more technical, I guess. But yeah, this one covers iMessage at the kernel level.
Yeah, I'll just really quickly interject. It does mention the 36 C3 talk. Yeah, 36. So like just just back in December. Uh, I mean, you obviously didn't attend it, I'm assuming, but this is essentially a more detailed version of that talk. I did give that talk a listen. I haven't given all of these a read, but I did
Okay.
give it a listen, and I mean, it's even as not doing a lot of iOS stuff. I got the gist of a lot of what he was talking about. He does gloss over things, doesn't go into anywhere near as much detail as you were able to when actually doing one of these write-ups. But I did just want to call that out that, there is a presentation there. Definitely worth a listen if maybe you're not wanting to get all the details, but do still want to kind of understand what's going on. It's worth it.
Yeah, I think this is one of the talks that I really wanted to see, but I slept through because jet lag. So,
Yeah,
you
apparently
know,
you slept through a lot.
the entire second day, pretty much in terms of talks. But yeah, so it's pretty cool. So he basically talks about how iMessages pass through all these services and frameworks before reaching the end user, and how some of those don't require user interaction. So one such service that he talks about is ImageEnt, I think is how you say it. Um, and this service actually is, I think it's sandboxed, um, but you can do it. You can hit it without user interaction. So they talk about some of the vectors they could actually use to hit the issue that they discovered. And the issue is actually in a function called nskeyed unarchiver. So this is used in different spots, and one of these is ImageEnt, which they ultimately ended up using. But they talked about kind of the decision making process of choosing that service, because the other big thing that they found that used it was Springboard. And I don't know how much you know about iOS, but Springboard is basically it handles the UI entirely. So like the home screen when you're browsing through your app icons and stuff like that, that's all handled through Springboard. And Springboard's kind of an interesting target just because it's not sandboxed. So if you can hit it, you have a lot more privileges out of the gate after exploiting it. Um, but because it's also handles all the core UI stuff, it's a very critical process. So they talk about like the advantages and disadvantages of hitting each. So they say Springboard would be nice because it's unsandboxed, but because it's so important and it manages the UI of the phone, crashing it is very noisy and noticeable. You have to respring, which involves the screen going black, showing the Apple logo, and going back to the lock screen. So if your exploit fails, it's very obvious. Whereas with this ImageEnt service, if it crashes, there's no like noise really made. You can crash it and then it'll just restart, and there's not much of a footprint left by that.
Yeah, and you might be getting to that, but I thought it was interesting. I ended up using the delivery notification to start exposing just a bit of information, but like a literal bit, not bit. Um, but yeah, I thought it was interesting how he kind of went about that by knowing that something might crash or might fail in one of these other services.
Yeah,
Yeah, keep going
yeah,
though.
yeah. So I was just gonna say, the issue is this NSKeyed unarchiver um, object I mentioned keeps a mapping of unique identifiers to objects, and they say it's so that objects can be referenced for multiple other same archive. So this is kind of getting more into that Apple lingo that I was talking about earlier. So I was kind of um I obviously don't do Apple stuff, so I could be wrong a little bit when I'm talking more on the tech. So I'm not entirely sure why they do that. But they say that the reference to the first or these objects is added before the constructor method is invoked, which is called a init with coder. Um, and basically, you can end up abusing that so that the first object is not fully initialized when it's referenced. So you get basically like an uninitialized read, and you can read from an attacker controlled address. And you can probably guess why that's a very powerful vector. Um, they do mention that there's some restrictions on this address, which is also really cool. They talk about a lot of the like struggles and decisions they had to make when writing this exploit. So some of the address restrictions was like it must be divisible by 8. It has to be lower than a 32 gigabyte address. But they say that most interesting objects are under that address anyway. So yeah, like they talk about how you could abuse this. Now, this article, you can't fully exploit it. They say that you need an info leak, and that's where they kind of get into the second article, which I haven't read yet. But yeah, the big thing there is like the arbitrary address read through the uninitialized field there, and yeah, it seems like a really cool issue. That being said, obviously you do need that information leak, and I haven't read that, so I would like to go more into that as well because it is an important piece of the puzzle. But it's just one of those things where I just didn't get around to it. I don't know if you have any light to shed from the
No,
talk. Maybe you talked about that.
no, not really. Like a lot of the technical details were glossed over during the talk. I mean, it was only an hour-long talk.
Yeah, I mean, obviously,
That's
you
why
have
I
to
was
skip a lot in the talk.
that's why I was kind of just recommending the talk, because if you want to have a bit of an understanding as to what's going on, but definitely not like you're not going to go and write one of these same exploits or something after that. Like it's more like the casual understanding. So no, I can't really shed any light on that.
Okay, that's fine. I just wanted to wonder if there was anything I missed from the talk because I haven't watched it yet. So yeah, they mentioned that the issue was fixed in 12.4.1. So that is actually fairly recent. It was released in August of 2019. So if you have a phone under that version, you could try playing around with it if you wanted to. But yeah, it's a pretty cool series, and I am going to be reading through part 2 and part 3. Just because Apple stuff is usually pretty interesting. I think it'll be kind of difficult, especially when you start talking about Article 3 when it goes into PAC and stuff like that. But I think there's a lot of valuable information there. So yeah, I definitely recommend it for anybody. This is there's not a ton of stuff out on kernel exploitation really, and I think this is one of those series where you might want to read it, especially if you're looking at getting into Apple kernel exploitation. So yeah, overall, just a good read. And the guy who wrote the write up is really talented in this stuff, so it's definitely worth checking out. So I guess we'll move into some of the papers. We have the WAF-A-MoLE paper, but it doesn't seem to be loading on our browser. So
Oh well,
let's try
that's
reloading it.
no. I mean, if it doesn't load, it's not going to load. I'm not too sure why that is.
Oh well, happens sometimes.
Yeah, that's definitely unfortunate. Allow me just to try and open up the original PDF at least, and I'll talk through it.
Okay.
But yeah, this isn't all that complicated to understand or anything. WAF-A-MoLE, evading web application firewalls through adversarial machine learning. And the idea here is it's basically it fuzzes the WAF. It only focuses on one really specific case, which is the admin or 1 equals 1 SQL injection. So you're probably not going to. Well, at least that's what their example works. They've released a tool that it basically. The idea being that there are certain WAFs that actually are, machine learning based and kind of learn based on the inputs that have come in and stuff. And this is looking at trying to attack those also. I mean, it's a mutation based fuzzer. Nothing too crazy, nothing that you wouldn't really expect. I just thought it was, it's a little fun. It does, you can actually, right up at the top, you'll see the example there. It can rewrite the admin or 1 equals 1 to, 0x1 or 1 equals 1 or 0x17 not equal to this, or adds all those things. Kind of create a query that's semantically the same but looks very different and may not match the machine learning model that one of those web application firewalls actually has.
Yeah.
So it has a few different mutations. You can see there it does some case swapping, like in the select keyword. It'll add comments, rewrite comments. It'll do different encodings of integers. It'll operation swapping. So using a like query instead of an equal query. Logical invariance. That'll basically just always be true or false as necessary. I think it only really does ones that are true. But yeah, I mean, that's effectively what it is. I just thought it's a neat little tool there. I think the tool itself and source, if you Google it, actually came out 4 months ago or so, but the paper was just put out.
Okay. I don't remember exactly what you said, but I do remember that you were kind of thinking when you read the title of the paper and
I
looking
thought
at
it
it the
would be
first time, you thought it
using
was.
machine learning to break the web application firewall.
Yeah, I was thinking like I know you thought it would be I guess more impactful than it ended up being, but it was still cool.
Well, um like I said, my initial thought was it was going to be that. So then when I saw, oh, it's just, a fuzzer, just a mutation based fuzzer, has some interesting rules, but whatever. It's not what I thought it was. Therefore, let's not talk about it. And then I actually gave this a better read. No, I like it. It's kind of cool anyhow. I mean, it's nothing like I think anybody listening to us kind of gets the point. Like you could see these two queries, and I think if you kind of understand SQL injection, you know exactly what this thing's kind of doing.
Yeah.
And this thing does look at, to be clear, it actually looks at how long or how many attempts it took before it was able to break against different systems, and like it's a study. They've actually looked at this, and you can probably derive some information about the security of some of these options, but I don't know. I just wanted to point it out because it is kind of a neat thing.
Yeah. So we did have another last minute white paper edition that you found. I think it was this morning. I haven't had a chance to read this at all. So
Yeah,
uh,
this literally did just drop this morning, which is quantum safe onion routing. If most of us are probably familiar with Tor, this is just an attempt to look at the impact of making Tor or having Tor using more quantum secure algorithms,
okay,
which is, I mean, the gist of it is, RSA. So I couldn't actually tell you too much. So RSA, AES, basically, are the two crypto systems that are commonly used. I believe that Tor is also using them. Key exchange in there, and then key exchange to get the AES key. So with that, RSA and factoring is broken by quantum computers, and then AES is broken. AES is like the significant break is it's like half the, not half. Like if you have 2 to the power of 128, if that's like the computation power needed, it's 2 to the power 64 with quantum computer. So it's not halved, but like the power is halved.
okay,
If that kind of makes sense. So like it's a very significant break. But if like AS 250 or AS 256 would be as secure as AS 128. In reality, that's not true. Don't quote me on that because that is not the truth. Because AS 256 in particular has some breaks that 128 doesn't have. There's a whole bunch of reasons why that isn't true, but the gist of it would be if you were to expand your block size, your key size up, um, if you were to double it, you would have that same security we have now on quantum. So it's not entirely broken like RSA is because just factoring becomes broken.
yeah.
Or at least more
Um,
significantly broken. That said, sorry, it sounds like you're trying to ask something.
oh no, you can go ahead. I was just gonna say something
I
at
was
the
just
end.
going to mention this. So this came out this morning. Admittedly, I have not kind of gone through everything on it. I just thought it was interesting to know that somebody is looking at doing quantum safe onion routing. I'm not a huge Tor user. I'm definitely a supporter of Tor. Like I think it's an important tool to have there. But like I'm not going around browsing all these, the dark web or something. I mean, my thought is all that information's on the surface web anyhow, or at least the information I care about. I'm not trying to hide. I'm not doing anything illegal. I don't like it's not like, the forms on there are somehow better or something. All the information's out
What do you
out
mean? It's the dark web. It's automatically better. I'll show you the way.
yeah, so that aside, I do think it's an important tool nonetheless. So what this is, so back in August, the same guy actually released, his master thesis, which was Sweet Onions, which is kind of the actual implementation of a quantum safe Tor. So
Okay.
this is more looking at the actual performance implications of different algorithms and things of that nature.
Okay.
how many cycles something needs, sizes of packets. It's just an analysis of it. I want to call it out though because it is nice to see that somebody's looking at that, and I think the actual results. I'll move here. It's on page 13 if you want to see what I'm pulling up here.
Okay.
Since we can't share it. It looks at. Sorry, just jumped up.
Yep, all good. Yeah, it is a pretty long paper, so scrolling through it does take a little while. So 13, yeah, I'm
Yeah,
on the
so
table you're
13
talking about
is
now.
yeah, well I lost it because it jumped up. It shows some of the algorithms that they've lost. Sorry about that. I hope I can be heard now. My mic just decided to cut out on me.
Awesome.
Yeah, so well timed. Love the dead air. But anyway, so they're looking at that. It kind of covers what actually happens, and you'll notice out of this, um, and it talks about like the message size, packets needed to do stuff, uh, time needed. No, so basically the lattice based, that's like lattice based crypto systems are all kind of faster, better performance than RSA. So this is in that initial circuit building that this table in particular is looking at, which is Kyber, New Hope, and Entru.
Okay.
So it's promising. At the same time, I don't know if we'll actually see this adopted, for real by a lot of people.
Yeah, it's one of those things where it's just we'll kind of have to wait and see.
Well, the issue is, so like I mentioned, the three algorithms there. Entru has a patent on it. So, like, you're not just freely able to use it. Now, they do have an open source exemption, but Entru is patent encumbered. Just because the patent's there, people are going to avoid it. New Hope and Kyber, I think, are both Creative Commons, but, like, I'm pretty sure both are less than 5 years old. Like, they're
So they're not
very
pure?
new. They're not mature.
I mean, one thing I will say about this paper, obviously, I haven't gotten a chance to really read it, but I think it's nice that there's already people starting to look at this kind of stuff, considering
This should
like
have happened a
or
while ago. People should have been looking at quantum stuff. I think we're too close to the possibility of I won't say I don't think we're that close to
I
really
think we're over a
practical
decade out.
consumer level. It's just I think we're too close in the sense of government already
Nation
having it or
states.
possibly already having it. Because the government's usually a fair bit ahead, or at least like the U.S. government and stuff are oftentimes like a good bit ahead. So
I
if
mean,
we're going to see the consumer level, I have to imagine they've already had it for a
doesn't
little
NSA
while.
already have a quantum computer? I think they already have one, don't they? Am I wrong?
Well,
I feel like I've heard about it, but
well, I
I don't
mean
want to like say for
there
sure.
are quantum computer. We don't have any confirmed true quantum computer yet, like for general sort of computation, NSA or otherwise. NSA wouldn't admit it if they did.
Oh,
There
absolutely
is
not.
like Deep Wave, and like that's I think Google's one. Um, like there are a few things out there. Either way, I just think we're somewhat close to actually finding this. Or sorry, actually, I think this should have been looked at a while ago.
Okay, but I still think it's better. At least it's looked at now and not after, like
Oh,
it's
for
already
sure.
out. You know what I mean? Like I just
Yeah.
wanted to say, like it's nice that there's at least people looking into it, even if it is a little bit late. In your opinion, like it's still before, it becomes an issue, and that is like a lot of things in security. It's kind of an afterthought, whereas this seems to be, they're kind of trying to get ahead of it at least a little bit. So that's one thing I was thinking about this paper when you
Yeah,
went through it.
well,
I was
I,
like,
I
okay,
guess I'm glad somebody's kind of tried to pick up the torch for Tor, an open source project. I'm not sure how involved the U.S. Navy, still is with Tor. I don't know if there's still active developers on it or not. But yeah, I mean, it's nice to see somebody kind of picking that up and trying to, because it is, I think, an important tool for like journalism, whistleblowing, um, being in some of those more restrictive countries. Like there's a lot of places where it can be used. So it's just a nice project. So I want to kind of mention this. This just dropped today, so I haven't had a chance to really go into too much detail on the specifics of what's covered there, but yeah, it's just nice to see.
Yeah. So we'll cap off the show with some fun shout outs. So you linked a few blog posts, mostly related to games. So the first one is browser games aren't an easy target. So sticking to that theme.
It's a straightforward write up. I just thought it was kind of interesting to see. This is one of the first time I've seen a write up talking about a WebAssembly. Rather than, like, obviously we've seen stuff for Flash. Well, maybe not Flash too much anymore, but this time it was a game that used WebAssembly. Interestingly, it actually used the WebAssembly stuff was written in Rust.
Yeah, I saw that too. I was like,
which was
okay,
just kind of just interesting. That's really all you can say about that. But yeah, it's just a really quick little write up here about how we did some analysis. What I don't like is that basically you've got WebAssembly kind of getting reasonable adoption at this point across the browsers. So you immediately have people doing obfuscation through WebAssembly, which is essentially what it is. They used WebAssembly just so they could obfuscate some of their game code. I mean, it's basically expected, but I'm definitely not looking forward to seeing more of this, but we're going to see more of this. So yeah, just a quick write-up. Want to give a quick shout-out there on it. I don't want to go through it. And the other one that I want to comment on is reverse engineering the random number generator in a Game Boy Advance game. One, I think it's fun to look at kind of the little game console stuff, but speedrunning does some crazy stuff, and this guy, I guess, is doing this for speedrunning purposes.
And they call it tool assisted speedrunning, which I haven't really heard of that before. I'm not like big into the speedrunning stuff.
So I mean, speedruns in general do some cool stuff even without being tool assisted. Tool assisted is specifically like, well, so there's TazBot that will do like controller inputs literally, but generally speaking, tool assisted just means like on an emulator and you're crafting the perfect run by giving it all the inputs and like the exact millisecond to do those inputs. But it's basically using a tool. It's not a person doing it, so you're able to get everything just perfect.
Yeah, what that's like reading, it's kind of like time travel testing, so that like you clear one stage and then you use the tool to skip past that stage to test your efficiency on another stage, kind of thing. Is that kind of what it's used for?
So tool assisted speedruns are its own category of actually creating, like having a speed run and having the fastest tool assisted run. It's literally just, but you're able to optimize. It is in theory the perfect run.
I thought it was for like helping people speed run legitimately, like manually. I thought it was like to try to find those fast methods, kind of thing.
So it is. A lot of tool assisted speedrun strategies, like the strategy that tool might use, will be used by actual speedrunners, or by like human speedrunners. But sometimes it's just not practical to do that at all.
Okay.
I mean, sometimes, but anyway, touching on this, like, speedrunners though, like, I want to mention that Games Done Quick just happened. I think it just ended this weekend, which is kind of like a week-long speedrunning conference. That just happened. There's a Zelda run where they did a little bit of heap manipulation in order to cause one of the allocations to fail. So in order to cause a specific allocation to fail, so basically the thing blocking the player's path forward wouldn't allocate and they could just keep going. So like there's some fun stuff there, but the other big thing that they'll do is RNG manipulation. You'll want to get the RNG in just the right state so that you're going to get like easy enemies or get the drops you want from an enemy, something like that. So that's kind of the why for this right up there. It's a good analysis of just kind of how we went and did some of this analysis, but I did want to point out this is also one of those places where, if you're specifically wanting to look at the RNG, it helps to really understand random number generators. Like just having that background knowledge can help you. Because and this is especially true for RNGs, it's also true for crypto, they're usually magic numbers or specific things that are commonly done. So in this case, well, it's a good write-up, a good blog post. Like definitely not hating on it at all. But basically searching for the right numbers, you won't be able to find out all the same information. I just pulled up kind of a Wikipedia article here listing some of the key numbers that you might look for different implementations.
Okay.
It's just one of those things, like a lot of time could have been skipped by actually being familiar. And maybe he knew that but wanted to kind of do it manually. Like there's, to each their own. You have to gain the knowledge somehow too. It's just one of those things where, especially on that, there are these magic numbers you can basically look for and get all the information you want without doing as much effort, or without putting in as much effort. But yeah, good write-up. Just wanted to give it a really quick shout out, not go into too much detail of it.
Yeah, these articles look pretty cool. I did want to jump back a little bit to the first one, the browser games aren't an easy target. He did actually mention in that article that he was kind of prepared to get some flack just because, P is talking about cheating in a game that seemingly is like multiplayer and stuff like that. It basically seems kind of like a CSGO in the browser or something like that, just from like the looks and the screenshots that he had there. So yeah, like it's just kind of funny that he was already prepared for some of that flack, and he was like, "Oh, I don't care."
Yeah,
So,
and I think that's completely fair for him not to care. I mean, when it comes to this, first of all, I think a lot of people have done security who have done the like binary level security stuff have probably written cheats, or if you haven't written cheats, have looked at it, and like it's just maybe not everybody, in fact probably not everybody, but a very significant amount of people start by doing games because that's, you're in your teens, you've got a lot of time to waste, so you spend time digging into the games, and that skill set of, looking into building some game cheats definitely applies to doing your binary exploitation and stuff. Obviously there's a ton more to learn to get into the binary exploitation versus kind of the reverse engineering bit that happens with building cheats, but there's that overlap in like that mental space that you get into when doing them. So I mean, I understand people who hate on it, but when it comes to kind of the hacking aspect, I mean, I don't have any complaints about somebody having done it. I mean, it's an interesting thing to do, even if I think he mentions that. No, I'm thinking of somebody else. Never mind.
Oh, okay. I mean, it's kind of anecdotal, but I mean, stuff like this, like these like browser-based games and like cheats, or I guess another word for them is trainers back then, was kind of what got me interested in programming too. Because back when I was like little and stuff, and browser games were popular, back then it was Flash, it was AS2, so games were very easy to like manipulate because AS2 is it's basically you get it for free. It's just variables that you can modify. So people were making trainers and stuff in like VB6. The big game was like Club Penguin. There was like trainers for, and I thought all that stuff was like really cool and interesting, and that's what kind of got me interested into programming and stuff like that. So I really like these kind of articles that kind of bring me back to that, and I think that could be interesting to newer generations of people like that are like just coming up, maybe like kids that are like 10 or 11 or something, see stuff like this and they get kind of interested too, maybe.
I don't know
I
if this is quite what a kid's going to be reading.
This is a bit more high level than like when you're talking about WebAssembly and stuff like that, but along those lines, I think these kinds of things are really cool for that kind of like inspirational stuff for getting into it.
Yeah, I mean, I'll also just add, like, it wasn't necessarily what got me into it, but back in my teens, like, rather than looking for cheats, I used to look for glitches in games. So, like, the wall hacks, or not like wall hacks, but, boundary escape sort of things, and like that sort of like in-game glitch. But I mean, there's an overlap in testing for that, and like you're still thinking about security in that. And I mean, it's a really common way for people to kind of get their start, get that initial inspiration.
Yeah, it's always fun to explore the connection between like games and security and stuff like that. But yeah, that pretty much caps up all of our articles. We're still not entirely sure with later on in the week if I'm going to be doing the stream on the Friday. I might not. If not, most likely next week. I will be getting back to it. It's just I got to make sure. I've been doing some stuff with my computer and messing around trying to fix stuff, so I just want to make sure that everything's ready before I get back to the streaming. But yeah, we might get back to the streaming this week. I'll mention it on Twitter if we do, and in our Discord, which you can find on our site. So yeah. So I hope you guys all enjoyed the podcast. We will be back again next Monday at the same time. Z, do you have anything to add on to the end of that?
No, I think that's
we're all good. All right, cool. So yeah, we will see you guys again next Wednesday and possibly on Friday. But yeah, we will see you guys
next Monday.
Did I say? Oh,
you said Wednesday.
Yeah. Oh, I said Wednesday. Okay, sorry. Yeah,
we're not moving the podcast.
No, we're not moving the podcast. So next Monday, if not potentially on Friday. So yeah, we will see you guys then.